Hello everyone, my name is Ken. So this video will be a summary of how you can implement disaster recovery of an on-premise application to AWS. I have provided a detailed step-by-step instructions in the link down below, so do check it out. So these are the contents that we'll be talking about today. I'll start off with understanding what is disaster recovery, why do we need it, and what are the recovery objectives. Then we'll go through various solutions and methodologies of disaster recovery. We'll be comparing disaster recovery with backup and which application requires disaster recovery. And finally, I will share with you how you can use AWS itself for disaster recovery. So that will include the benefits, AWS services, shared responsibility, business impact and risk assessment, the implementation, maintenance, and finally how to respond in the event of a real disaster. And over here right at the bottom, I have guides on the chapters so you can follow along. So let's get right into it. Now, in terms of IT context, a disaster itself is defined as an event that partially or completely disrupts the operation of an application, while the recovery itself is a process of preparing for and recovering from that disruptive event. Now, there are 4 categories of a disaster. First will be human error, second will be malicious attack such as DDoS, third will be natural disaster such as an earthquake, while the last one will be technical failure such as power failure or network failure. Now, why do we need disaster recovery? Well, it's because we have revenue generating applications such as something that earns money through processing fee, and a disaster itself would cause the application to stop and inflict direct and indirect financial loss. You will want your company to be known for its good service instead of being known to be unreliable, so reputation is important over there. And finally, not having a disaster recovery strategy would be failure to abide compliance standard. For example, in Banking Act, failure to comply will result in penalties and fines. Now, as part of disaster recovery, your company needs to define the recovery objectives, which is divided into 2 types. The recovery point objective, which is essentially how much data you can afford to lose, and the recovery time objective, which is essentially how quickly you must recover. So we move on to see the various common resiliency solutions practiced today. First one will be backup, where historical data are stored locally, remotely, or both. Then we have archiving, which is actually a subcategory of backup, but since archiving is for long-term storage, it has very slow recovery. Then we have means of high availability, which is usually introduced at the design stage and is meant to handle small localized disaster. And finally, we have disaster recovery, which is having the ability to use a secondary application in secondary location. There's a common misconception that backup is disaster recovery. So let's compare both of them. For a start, backup is to gain access to lost or damaged files, while disaster recovery is to restore functions so that business can continue as usual. RTO and RPO doesn't apply for backup, while for disaster recovery itself, it implies replicating critical application to perform failover quickly. As for resource allocation, backups are stored in compressed state and do not need to be restored quickly, while disaster recovery requires a separate site that should be ready for possible failover anytime. So how do you determine which application requires disaster recovery? The answer is to calculate the return on investment and the total cost of ownership, in which we'll do it in section 3. So let's get right into it. Now in section 3 onwards, we'll be talking about disaster recovery specifically on AWS. First, we'll look at the benefits of using AWS for disaster recovery. The first benefit will be elasticity, where there's no need to commit a set number of servers. Then we have low cost of ownership because you only get billed for the services when they are provisioned. Third, you can achieve RTO and RPO within minutes. Fourth, it supports most applications running on x86. Fifth, it supports a wide variety of operating systems. Then AWS also supports ASIC-compliant applications and databases such as Microsoft SQL Server. And lastly, you can add disaster recovery capability without redesigning the whole architecture. So what are the AWS services that we can use for disaster recovery? First will be the Elastic Disaster Recovery or AWS DRS. It continuously replicates application and databases to AWS. So during normal operation itself, DRS will replicate changes to the source data to the staging area in your AWS account. And when a failover happens, stage resources are deployed in disaster recovery site. And after a disaster is over, you can use DRS to fail back to the primary site. The next tool that we have is AWS Data Sync. which is an online transfer data service, and it can be used to transfer an on-premise storage system to AWS or between AWS storage services. Now, DataSync also supports a variety of data systems such as NFS, SMB, S3, Snowcon, and many more. Lastly, we have Amazon Route 53 Application Recovery Controller, or ARC. It gives you insights on whether your application is ready for recovery. What it does is that it ensures provision capacity matches across all AZ and regions. Now, it's important to note that when we use AWS, both customers and AWS have shared responsibilities. Customers have the responsibility in the cloud, whereby they are responsible for securing the data, the workload architecture, change and failure management, and also networking constraints. As for AWS, they are responsible for resiliency of the cloud by providing a reliable hardware and service for a variety of services in compute, storage, database, networking. AWS is also responsible for the global infrastructure across regions and availability zones. Now, before we go into implementation, we should do a little bit of risk assessment and impact analysis to calculate your maximum total cost of ownership. How we can go about this is to categorize the disaster type, then the likelihood of it happening, what is the consequence in terms of cost, and finally, you get the risk by multiplying the likelihood and consequence. So here we have another example of power outage, which has a 5% likelihood of happening, but 150,000 in terms of consequence. With that, you get 7,500 as the risk. When you sum out all of this, you get the total risk, which is actually your total cost of ownership. Now, there are a variety of disaster recovery solutions on the market. When you look out for solutions, make sure they matches your criteria in the following factors, such as source application support limitation, which is usually operating systems or CPU architecture. Then you have recovery point objective, recovery time objective, total cost of ownership, compliance, ease of operation, ease of disaster recovery drills, and level of automation. After you have selected the disaster recovery solution, you need to plan the implementation project. So here are the general steps in planning. First, you will need to map the resource within the application. So this will document the dependency of the application. Next, you define the realistic timeline so that it matches the complexity and the experience of the people involved. Third, plan the people and team resources. Fourth, estimate the cost of this project. It should include the cost of data transfer and provisioning the AWS services. 5. Choose a solution for each disaster recovery. And lastly, define your success criteria. Now that we have finished planning, you can go ahead with the implementation. So here are the steps. Group the application into waves. Now each wave should include applications that are designed to work together so that every wave can be tested individually without being obstructed by dependency on resources. Next, you configure the staging area. Now, it is generally recommended that you have a dedicated subnet so that it will not interfere with other processes or even compete with private IP. Use multiple AWS accounts. As part of the AWS best practices, it is recommended to use dedicated AWS account for staging area and recovery sites. This is to prevent AWS API throttling from happening. Next, network consideration. Isolate the recovery subnet to prevent conflicts with the source location. This can be done using route rules, network access control lists, or by associating with appropriate security groups of an application. And finally, mapping the application structure. You will need to map the application network and server configuration so that it comes in handy during disaster recovery. So here are the general process for each wave. First will be define the replication setting, which includes configuring your staging area and security groups. Then install AWS replication agent. Third will be launch setting configuration. After replication has started successfully, configure that launch setting for each server to define how your drill and recovery instances will be launched in AWS. Fourth will be testing, and lastly will be cleanup. Now, a disaster recovery solution requires regular maintenance after implementation in order to ensure that it will work as expected during a disaster. Now, there are two parts of a maintenance, which is monitoring and periodic drills. So let's look at some of the monitoring methods. The first will be built-in monitoring capabilities if you are using services such as AWS Elastic Disaster Recovery or AWS DRS, in which you can monitor and interact with from the source server page. Next, you can also use various AWS services such as Amazon CloudWatch, Amazon Event Bridge, and Amazon Simple Notification Service or Amazon SNS. And lastly, you can monitor using APIs of AWS services such as the AWS Elastic Disaster Recovery or AWS DRS. You can refer to the full list of APIs in the link down below. Now, once you are done with monitoring, you should also do periodic drill of disaster recovery because frequent drills will give confidence to stakeholders. The organization should decide on the frequency of the drill because if it's done too often, it's a waste of resource. And if it's done too infrequent, there will be less confidence. As a general guide, it should be no less than once a year and no more than once a quarter. So how do you respond in the event of a disaster? Well, you simply perform a failover, which is very similar to a drill. The difference is that users will be redirected to the disaster recovery site, and that failback will be needed when disaster is over. So these are the steps. You launch recovery instances for single or multiple source server, then you perform the actual failover by redirecting traffic. And once the failover is done or the downtime is over, you can prepare for a failback. Now, once your primary site is available again, you will want to perform a failback and return to normal operations. So here are the steps. Start by replicating data from the disaster recovery site to the source site using a failback client. You can continue to use the disaster recovery site while data is being replicated. Now choose a failback window that minimizes impact on the users. And during the failback window, go to the disaster recovery site and stop the application. But make sure that all the data finishes replicating to the source site. Then start the application on the source site. Make sure that they launch correctly. And once it's ready, you can now redirect users back to the source site. So there you have it. Disaster recovery of an on-premise application to AWS. Now if you like this video, please give me a thumbs up. And I'll see you again soon.